We are at question 4 for exercise on finding directional derivative. Now, remember, if you got stuck anywhere, right, you should still make an attempt. Make a genuine attempt at working it out. You follow the steps that I outlined and do all of that before you watch my solutions, all right, to the workout. Now, here we have f of xy equal x cubed plus y cubed minus 3. You're to find the directional derivative at 2, 2 in the direction of the vector square root of 2, square root of 2. Just a reminder that I'm under the, what they say, under the weather of the flu. My voice isn't that clear and I have to be coughing some of the time. Alright? Now, remember the steps. First of all, you outline your strategy. You're going to find the directional derivative of the function, which is the dot product between the gradient vector and the unit vector, right? Now the gradient vector is equal to delta f by delta xi plus delta f by delta yj. So the gradient function in this case, the gradient vector in this case, delta f by delta x is what? It's going to be 3x squared. Alright, that's it. I didn't need this bracket. It's just one thing. So it's 3x squared I plus delta f by delta y is what? 3y squared j. Okay. That's it. Now, we are looking at it at these particular points. So at 2, 2, it is 3 times 2 squared I plus 3 times 2 squared j, which is what? 2 2's 4, 4 3's 12, 12i plus 2 2's 4, 4 3's 12j. Okay. Alright. So that's what we have as a gradient vector. The unit vector now. So another way to write unit vector. Alright, let's look at the 3 main ways to write it. You can write it as a column vector as written up here, which is the same thing as you could write it using angle brackets as here, which is the same thing as square root of 2i plus square root of 2j. Alright? Same thing. But the magnitude is the square root of square root of 2 squared plus square root of 2 squared. Alright? So remember, it's like you have square root of 2i going this way, square root of 2j going this way, and then the hypotenuse of that right angle triangle, giving the magnitude. So it's going to be what? The square root of 2 squared is 2 plus square root of 2 squared is 2. 2 is 4, so the magnitude is 2. Alright? So the unit vector is going to be the square root of 2 over 2i plus square root of 2 over 2j. That's the unit vector. So now the directional derivative is going to be 12i plus 12j dot square root of 2 over 2i plus square root of 2 over 2j. Now remember, the dot product, you're multiplying the vectors, but it's direction. You cannot mix up the I and j. Remember, it's not a case where you have this time this plus this time this plus this time this plus this time this, as when you're expanding binomial in brackets. That's not the case. It's I by I plus j by j. Not the i's and the j's. The number in front of the I times number in front of I plus number in front of j times number in front of j. I and j are showing the directions, right, of the vectors. So it's going to be 12 times square root of 2 over 2 plus 12 times square root of 2 over 2, right? So it's 12 by square root of 2 over 2 plus 12 by square root of 2 over 2. That's just what just happened. So 22 and 26, 12, 6. 6 square root of 2 plus 6 square root of 2. So it is 6 and 6, 12. 12 square root of 2. Alright, so in that case, that is the directional derivative of this function.